everyone, first of all, thank you for being here in my YouTube channel. Let's talk about Kirchhoff's laws. So Gustavo Kirchhoff introduced this laws, and then KCL and then KVL will be there. KCL is a Kirchhoff's current law. KVL is called as Kirchhoff's voltage law. KCL is also called as law of conservation of charges because current will be there, Q by T will be there. And Kirchhoff's voltage law is also called as law of conservation of energy or work done. Voltage is equal to work done by unit charge. So first one, KCL, the statement says algebraic sum of the current meeting at a junction is equal to 0. So this is the equation for remembering purpose. Sigma I junction is equal to 0. And also entering current is equal to leaving current from the junction. The statement. You can write any one statement. Okay. So I have taken an example over here. See, I1, I2, I1 is entering, I5 is entering, I4 is entering to the junction. I2 and then I3 are leaving. See here, I1 is entering positive. So entering node is taken as positive, leaving node is taken as negative. So I2 is leaving and then I3 is also leaving. So I4 is entering, I5 is entering. So sigma I is equal to 0 from the statement. So it is proved. And I have taken another one example. So I1 and I2 are entering into the junction. I3, I4, I5 are leaving from the junction. So entering current is equal to leaving current. So this law is applicable to how much current is flowing through the particular branch that we are going to measure by using KCL. So we'll discuss one in detail KCL because very important to solve the problems. So this one is a node. So I1 and then I2 are entering. So is equal to I4 and I3. Correct, right? So entering current is equal to leaving current. So I1 plus I2 is equal to I3 plus I4. So I think you understood the concept of KCL. Next there is a KVL. Algebraic sum of the voltages around the loop is equal to 0. You can say sigma EMF plus sigma I into R is equal to 0. Okay. So algebraic sum of the voltages and then voltage drop is equal to 0. So see the circuit diagram, guys. This is we'll apply a loop equation over here. V1 plus V2. So negative to positive. That's why I have taken positive V1, positive V2. Okay, V2 plus V1 or V1 plus V2. V2 plus V1. Okay, anything is fine. So V1 plus V2 minus I into R1 minus I into R2 is equal to 0. I can say this one is VR2. This one I can say VR1. So V1 plus V2 is equal to IR1 plus I into R2. So I into R1 is what? According to Ohm's law, V is equal to I into R. So here VR1 is there. VR1 is equal to I into R1. So V1 plus V2 is equal to I into VR1 plus VR2. We can write entering supply voltage is equal to drop across. Some of the drop across each resistance, right? So if you want to calculate current, so from this equation, so V1 plus V2 is equal to I into R1 plus R2. So I is equal to V1 plus V2 divided by R1 plus R2. This is the current equation for KVL. Just you apply the loop equation, get KVL. Even one voltage source and then two resistance also, okay, fine. You can calculate voltage, current, and resistance value also. So I have taken on another example to understanding the KVL. See here. So I start with here. Okay. So E1 negative to positive. So I just taken positive E1 minus I1 into R1 minus I2 into R2 plus I3 into R3 because opposite, right? Plus positive minus E2 plus I4 into R4 I can write, right, is equal to 0. Algebraic sum of the voltages around the loop is equal to 0. Sigma V is equal to 0. See here, E is also V and then this is IR1 is also V from the Ohm's law. So I'll write the equation. So E1 minus E2, I'll rearrange the equation, is equal to I into R1 plus I2 into R2 minus I3 into R3 minus I4 into R4. See the equation over here. So this is a equation. Don't take one current here from here to here, but because they mentioned I1, I2 and then I3, I4 separately, because this is a junction. Okay, don't confuse. Next, there is a number of resistors are connected in series. See, this voltage is equal to sum of all the voltages. This V is equal to V1 plus V2 plus V3. The number of resistors are connected in series, so R equivalent is equal to R1 plus R2 plus R3. Correct, right? Just you add resistances. If you want to calculate current, I is equal to V by R1 plus R2 plus R3. Correct, right? So next there is a parallel circuit. So the parallel circuit, so current will be dividing here. But in the series circuit, current will be same. Keep it in your mind. But in the parallel circuit, current will be different. Okay. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. For remembering purpose, R equivalent is equal to R1 parallel to R2 parallel to R3. Right? So if you want to calculate I is equal to V by R equivalent. This is the equation in ampere. Okay. Let's see one best example to understanding purpose. So just this one you take one person home. This one you take other person home. This is a series circuit. Current will be same. So switch will be there. If suppose switch is closed, so current will be flowing both the homes. I mean both the lamps. Okay. Suppose here this is a parallel circuit. Current will be different because this is a parallel. It will be dividing here. If suppose this switch is closed, so what happens? The current will be flowing here and then here also. Whatever we are using in a domestic purpose, always it is parallel connected. Because if suppose failure occurs here, it will not affect it to this lamp. If suppose lamp will be burned out, what happens? Open circuit, light will not be glowing another lamp. So that's why the electrical connection from grid or from government, that is parallel connection. General question. So whether in our home, whatever the electrical appliances connected in series or parallel, always parallel connected. Keep it in your mind. So I have taken one example just for your understanding purpose. I'll be giving values 1, 2, 3, 3 or 4. Okay. So I'll take this voltage value 20 and here 30. I will be calculating current I. I is equal to V by R equivalent. So voltage is 30 plus 20, that is 50. Total is 50. 50 voltage. And then we need to calculate R equivalent. R equivalent, how to calculate? R equivalent is equal to 1 plus 2 because series plus parallel combination of 3 parallel to 4. Okay. So 1 plus 2, 3, 3, 3 and plus 3 into 4, 12 divided by 7. So finally you'll get 1.71 plus 3 is here, 4.71. So 4.71 is the R equivalent. Okay. So I is equal to 50 divided by 4.71. Just to calculate the value. So next, the last concept, current, voltage, and power. Okay. So current flow of electrons, particular direction, particular conductor with respect to time, and then voltage, potential difference between 2 point charges or 2 points, or pressure is required to move the electrons. Power is also called as work done by unit time. Energy is power into time. Power is equal to VI. So just I have given on easy understanding of voltage, current, power, resistance relationship. So if suppose you want power, power is equal to V square by R, I square R, and then power is equal to VI. We can use. If you want to calculate voltage, V is equal to I into R. Power is equal to VI, right? V is equal to P by I, and then V is equal to root P into R. If you want resistance, similarly for this I also. So thank you.